or design bid build project, the contractor performs its own quality control measures. So they hire all the testing, they do all the recording of the information, so they do all the measurements and all that, and then the state, the agency, the client, whomever is going to have their own quality assurance team. So depending on the contract, this is gonna change who holds the responsibility for quality control. But for the most part, quality control is done by the contractor. The project management team should have a working knowledge of statistical quality control, especially sampling and probability to help evaluate and control outputs. So the management team should have a knowledge of the reports. So all the quality control outputs, they should have records of these. They should know what's going on. They should know how they should basically evaluate this and see if there's some more sampling or some different types of tests that they can do to better have this product, better to have the quality of the product become even more better. So that's the goal of quality control. Quality control is making sure that the monitoring and the recording of results and the tests being done are being in accordance with what's being asked for in the quality management plan. That all those checks and all the recording and the monitoring is being captured, and it's being captured in the DWR. Um, and everyone has rights again to look at the DWR. So some quality control flow chart. So we have our inputs. We have project management plan, quality matrix, quality checklist, like I mentioned, work performance measurements, approved change requests, deliverables, organizational process assets, tools and techniques, cause and effect diagrams, control charts, flow charting, so on and so forth. Outputs, quality control measurements, validated changes, validated deliverables, organizational process asset updates. Again, this is just for your own information. I thought this would be um, helpful and just more than what your textbook is providing. So inputs to quality control, we have our project management plan, quality matrix, quality checklists, and work performance measurements. So we have our planned versus actual technical performance, planned versus actual schedule performance, and planned versus actual cost performance. I recall a few classes ago I showed you a chart of what we believe. This is how the breakdown, this is how our performance should be going cost wise, and this is where we're at every single month. So that's just an input when it comes to work performance measurements. So you're just tracking pretty much the measurement and the work performance. Let's see for your textbook. Let's see if I can. Okay. Continuing for the inputs to quality control, approved change request, deliverables, organizational process assets, quality standards and policies, standards and work guidelines, issue and defect reporting procedures, and communication policies. So like I mentioned previously, some tools and techniques for quality control would be testing and inspection. That is on page 297 of your textbook. Okay. So what's the purpose of inspection testing? Examination of a work product to determine whether it conforms to the documented standards. Okay, so just before we move on, I just want to list also, your textbook has building inspector, their responsibilities. So the way this textbook has it, it's a vertical construction, and they see that the inspection is done by the building inspector that is sent out there to monitor if everything is in accordance when it comes to the standards and the local codes for that building. So they sent out a building inspector, and on page 302 of your textbook, it says the responsibilities of a building inspector. Just want to read this for you guys. So, inspectors are trained personnel in a specific area of inspection. Inspectors are independent and do not enjoy any type of gain from their decisions. Inspectors do not direct the contractor. Inspectors must make decisions regarding conformance to specification or codes, and inspectors can accept or reject work. You guys can read more on building inspection from page 302, 303, and 304. They're just going to go into the different types of tests that the building inspection service um, provides. They're also the laboratories. So on page 304, we see here it says areas that normally require outside laboratory and inspection services include the following. And they go on with the bullets here with soil testing, bolt torquing, asphalt testing, placement, condition of oil reinforcement. So we know that on a horizontal type project, we would have the quality control team doing all these tests. If there's any type of specific test requirement that is called for that quality control team does not possess, let's say that they don't possess a welding certification, then the contractor would have to go employ a third-party inspection agency, another inspection agency to perform that type of inspection. Um, where would you find out that you need this type of inspection or you have this type of work that require this type of specific inspection agencies? Of course, you go back to the RFP, to your contract documents. They will state what you will need, what type of tests are required on this project, and your quality control plan is going to lay out the certifications and the qualifications needed for this inspector to be on that project. So you have to meet the requirements before you have this inspection team or testing laboratory agency service go out there and provide these tests. And that's going to conclude chapter 11. Okay, so let's go to chapter 12 now. Chapter 12 is time and cost control. So we're going to start off with defining what planning and scheduling. So planning is a process of choosing the method and order of work. Scheduling is the process of determining the interrelationship of associated timings of operations. So those are just two definitions, planning, scheduling. So steps in construction scheduling. A lot of this information and software and critical path methods, everything that we're going to go into right now, construction scheduling, you have this, I believe you have classes in regards to this. So we're just gonna pretty much just go over this pretty quickly, this chapter. Just gonna give you an overview, things that you have applied in your other classes. This is just gonna be just a refresher. So steps in construction scheduling. So what's the first step? The first step is splitting of the project into work activities. Then you determine the logic relationship, interrelationship between activities. Does it make sense to have this activity start after that activity? What activities can I have go together? Do I need to have that activity complete before I can start the next one? So that's what you're going to be doing. Construction of network diagrams, assigning duration to different work activities, CPM calculations resulting in start times, finish times, and flow calculations of activities. That's something I believe you do manually, and you do on the computer software where you have your early start, early finish, late start, late finish. You have you're doing your activity to node method. So you're gonna mark the critical path once you complete that, and construction of bar charts, time phased. So the path or paths in the network diagram from start to finish on which all activities have zero total and free floats is called critical path. So basically with those activities, you don't have um, any wiggle room, I guess, when it comes to schedule or time. You can't squeeze nothing in and do anything or have that activity go longer than it's supposed to be. So whatever that duration is, that's going to be your finish time, and you have to go on to your next activity. So that's considered your critical path. You can't deviate from that because then it throws off your whole schedule. So it is the longest path or paths from start to finish in a network diagram. It gives minimal normal time to complete a project. It's usually marked by double lined arrows.